Hey, if you'd like to earn CEUs for this webinar, join the Safeopedia community at the link in the description below. Now on to the show.
Well, hello and welcome everybody. Whether you're joining from across the globe or right next door, we're honored you're spending your time with us today. My name's Scott Cuthbert from Safeopedia. Our mission at Safeopedia is to support and uplift safety leaders with the knowledge, resources, and community they need to help make workplaces safe. Before we get started, I just want to thank everyone for attending. And again, thank you for all of the great work that you do behind the scenes. A lot of times it goes unnoticed, but the impact that you have on families, communities, and organizations is profound. So thank you so much for everything that you do. At the bottom screen under the three dots, you'll see Q&A. So as the presentation's going on, if you have any questions, please drop them in the Q&A section, and we'll do our best to get to all of those questions at the end of the presentation. Today's webinar is Navigating Welding and Grinding Hazards. The webinar has been made possible with the support of 3M, a preferred manufacturing member of the AD Safety Network and a longtime supporter partner of Safeopedia. So thank you, 3M. Our presenter today is Scott Shin from 3M, who will be walking us through a system-based approach to welding and grinding safety grounded in working together philosophy. With that, it's my pleasure to introduce the presenter, and I'm going to turn it over to Scott now.
Great. Thank you, Scott. My pleasure to be here. My name is Scott Shin. I am an application engineering specialist with 3M Personal Safety Division. I've got roughly a little more than 37 years experience in the health and safety field. Some of that in consulting, the chemical industry, and the last 20 here with 3M Personal Safety. My primary role today is supporting what we call our heavy machinery and primary metals customers in the proper selection and use of personal protective equipment. So we'll go ahead and get started. Before we do that, for those that have seen 3M presentations before, you've probably seen this slide, just a few opening points, and you can read it as we go. But to summarize, just be aware that this presentation is based on current US and Canadian standards and regulations. These may change in the future, so just be aware of any changes that might occur. And we always want to remind people that you should always be reading and following user instructions for whatever PPE it is decided to use. With that, we'll start going here. So I think we all know that welding and grinding is a challenging and hazardous occupation. Many different types of hazards, risks present in the process. You see quite a few of those listed here. Way too many to cover in the short time we have today. So what we're going to do is just focus on a few of these. And these will be respiratory hazards, head hazards, noise, eye and face, foreign body, arc radiation hazards. And then we'll talk a little bit about the technology in the auto-darkening filters that are in today's modern welding helmets. And lastly, follow up with some tips in how we choose the right equipment to protect workers from these welding and grinding hazards. So one more comment before I get going in the presentation. I know we all love personal protective equipment, PPE, but just as a reminder, PPE is the least preferred and least effective of the controls. So just a reminder that when we look to reduce risk in the workplace, we should always be following the hierarchy of controls, which I have shown here. I'm sure you've all seen that in the past. So let's go ahead and start with respiratory hazards. Right. So first, just general comment, all welding produces metal fume, right? And a metal fume is created when you strike that arc, that metal or a portion of the metal is melted and vaporized, and that vaporized metal immediately condenses into a very small particle called a fume, right? So I'll talk a lot about welding fume, and that's what a fume is. It's a particle and a very small particle. But there's also potential for gases and or vapors, depending on the process and metals and whatnot used in that process. So we'll talk a little bit about those as well. So here's some examples of what may be potentially present in the welding plume, right? And it's really going to vary depending on again, the base metal and the consumables and the process, right? So if you're welding on aluminum, obviously the majority of the fume generated will be aluminum oxide fume, right? Steels, right, are all iron-based, a lot of iron oxide fume. Manganese is another one we hear of quite often. Manganese is present in all, if not, or most, if not all, of steel and aluminum alloys. And then the nickel and chrome, those types of metals are found in stainless steel. And right, these can be, again, generate fumes, oxides during the welding process. Now, gases and vapors are really going to vary depending on your welding process, right? Some involve shielding gases such as argon or carbon dioxide. Some include fluxes. These fluxes may produce components such as various fluorides, hydrogen fluoride, maybe nitrogen oxides in the process. Ozone can be created in some welding processes. And then if there's contamination in the weld area, it could off gas or create different combustion products, acid gases, organic vapors, that sort of thing. So be aware of the process, be aware of what might be generated, and these should all be incorporated again in your risk and hazard assessment. And then there's a number of common health effects that we can expect, again, on overexposure to welding fume and welding exposures. These can include, acute short-term effects such as nausea, headache, dizziness, metal fume fever, which I'll talk about a little bit later, along with some long-term chronic effects from long-term exposure, overexposure, asthma, obstructive pulmonary disease, CNS damage, systemic toxicity, and even some forms of cancer. Right. And just to note, right, we talking mostly about welding, but grinding is also a very important part of the process. Grinding also creates particles that can be inhaled and may reach the lungs. Now, generally, these grinding particles are larger than welding fume. Welding fume is extremely small and can be inhaled deep into the lung. Grinding particles tend to be a little bit larger, sometimes a lot larger, and may not be as likely to reach the lungs, but still, again, need to be considered in your exposure assessments. All right, so I mentioned metal fume fever. What is metal fume fever? It's generally associated with exposure to zinc oxides from the welding grinding process. So think galvanized steels have that zinc galvanized coating. And you can see on the image on the right here, you can see where the galvanized coating is vaporized away from the weld bead, right? So again, that vaporized zinc condenses to form zinc oxide fume. And overexposure to this zinc oxide fume can produce flu-like symptoms we refer to as metal fume fever. Typically starts 2 to 3, 4 hours after work, and symptoms can generally subside 24 to 48 hours after exposure. So typically it's been a very common health effect for welders in the past, not so much anymore, but still certainly a potential. Another exposure we tend to talk a lot about is manganese and manganese oxide. Manganese is present again in most, if not all, aluminum and steel alloys. As a hardening agent in some cases. This manganese oxide fume, when inhaled, can get into the gas exchange region of the lungs, right, and be absorbed into the bloodstream. This can lead to some very severe Health effects. We commonly we call this manganism, right? It's a neurological disease that can include loss of balance, weakness, tremors, mood changes, short-term memory loss, paralysis. So manganism, right? Something that's been in the news quite often over the last, 10, 15 years. But something that's come up more recently is the potential for ototoxic effects. So what this means is that overexposure to manganese fume may lead to harm or may be harmful to your hearing when inhaled in significant doses. So it's an ototoxic agent, and the science and the studies of this as well as manganism do continue to evolve, and there's new studies coming up all the time. Then we also like to talk about chromium exposures, specifically hexavalent chromium. So as that chrome metal vaporizes, again, condenses, is oxidized, a portion of that chromium oxide can be present in the hexavalent form, right? And that's inhaled into the lungs again. And this is important because hexavalent chromium is a known human carcinogen. Um, so there's risk of lung cancer, risk of nasal cancer. Skin contact can cause irritation, ulcers, and maybe allergic reaction. So again, hexavalent chrome, a very severe health effect. And this is typically why if you're welding on, well, we like to say if you're anytime you're welding, right, respiratory protection should be considered. But we like to promote mandatory use of respiratory protection when welding on stainless steel. One last point on the hazards. Fairly recently, back in 2017, the World Health Organization did name welding fume as a class 1 or known human carcinogen. So traditionally, we've known compounds like nickel, chromium, and such have the potential to lead to various forms of cancer. But this designation and some studies referenced to lend one to believe that even welding on mild or carbon steel can be a cancer risk. So just something to be aware of. Now, the exposures do depend on many different factors, right? The length of exposure, worker position, the voltage speed, the type, and shielding method used, the base metal. But we be aware that about 90 to 95% of the fume that's generated does come from the consumable, from the electrode wire or the rod, right? So I would make it a point, right, to always review the safety data sheet for the consumables that you're using, that are used in the workplace. This will give a really good idea of what risks might be present during the welding process. Now, as far as respiratory protection, any NIOSH approved respirator with a particle filter, right, can filter welding fume and particles and grinding particles. Because like I mentioned before, welding fume is a particle. Now, if there's other contaminants present, gases or vapors, you may need to combine that filter with a gas vapor cartridge or some other form of respiratory protection, right? And this protection, right, there's many different options, everything from a simple filtering face piece respirator for particulate only, a half face piece respirator, all the way up to integrated systems, supplied air systems, powered air purifying respirators with integrated welding, grinding head tops. So it is important to know what the exposure is and what level of protection is needed, because each class of respirator does have its own assigned protection factor, right? So as your exposures increase, your assigned protection factor needed will likely need to increase. Okay, so let's talk a little bit about head protection. Okay, this is a little bit simpler. right, than respiratory protection in most cases. There's three basic types of head protection, starting with the simplest and lightest, which is going to be a bump cap. This is designed to help when you are just worried about bumps or bruises or lacerations. If you're working in a tight space, you've got racking or pipes, in the way, you need to get in a weird position inside of a vessel and whatnot. A bump cap may be a good option here. This does require a fairly new ANSI standard, 100-2024, which does specify certain test requirements for bump caps. More commonly, what we see is hard hat use, right? These are designed to help protect you from small falling objects. And I do want to emphasize these small parts, right? So very large, heavy objects are typically not going to be, or hard hat is typically not going to protect you from some very large, heavy objects. But the ANSI Z89 standard or the CSA, the Canadian standard Z94, these specify the test requirements that these hard hats need to meet. And more recently, we're seeing a pretty good adoption in some industries, at least, of what we refer to as a safety helmet. These again are designed to help protect you from smaller falling objects. But this offers the security of a chin strap. And there is an ANSI standard, again, that the same ANSI standard Z89 that these safety helmets are required to meet. So if you've never seen the impact testing done on a standard hard hat, this is an example of the penetration test, in which a 1 kilogram missile is dropped at 23 feet per second on the very top of the hard hat. And to pass the test, no contact is allowed to the head form. So this is the penetration test. There's also a force transmission test. With this force transmission test, a 3.6 kilogram object is dropped 18 feet per second, right? And the force is measured to the head form, and the force cannot exceed 1,000 foot-pounds at impact. So just an example to see what type of testing is required on a standard hard hat. And again, lots of different options for head protection for welding and grinding, from a standard hard hat with the attachable welding helmet, shield, or grinding shield, all the way up to integrated respiratory protection with head protection, face protection, or welding protection. So again, lots of different objects, or lots of different options, sorry. Good. And the last thing I will talk about today is noise exposure. And noise, as we know, is everywhere, right? And the welding process, grinding process is no different, right? So depending on the process, again, the sound levels may vary, right? For traditional welding, typical welding process, anywhere from 85 to 102 decibels may be generated. Grinding a little bit louder, maybe up to 105, 109. And then extremely loud noises from air arc gouging or abrasive blasting, right? In this case, sometimes dual protection may be needed. Now, generally, continuous or prolonged noise exposure above 85 decibels is considered hazardous, right? And can lead to what we call noise-induced hearing loss. And this is a permanent loss of hearing. It cannot be recovered. The good news is, though, with noise-induced hearing loss, it is 100% preventable, right? And very simple to protect workers, right? With proper selection, use, and fitting of various types of hearing protection, from a roll-down plug, a reusable plug, push-ins, various types of ear muffs and communication devices. It is fairly simple, right, to protect workers from hearing protection. Okay, so that is it for me. I'm going to pass this over to my colleague Mike, and he will continue on from here.
Well, just that simple. Thanks a lot, Scott. My name's Mike Hallock. I'm a senior application engineer here, also at 3M. I actually specialize in welding and welding PPE. With that, I've been asked to talk about a few things. let's get into it. Meanwhile, you've seen me. I think I'll hide myself so you don't have to watch me present. Ion phase impacts and foreign body hazards. Oh, wrong button. Sorry. I don't think it's any big surprise, but flying impacts, particles, and objects account for 31%. Foreign bodies, that's everything else that just magically appears in your eye, it's 26%. For those in the chemical industry or even cleaning agents, 14. And because we are talking about welding, radiation from welding arcs, which I'll go into in quite a bit of detail. What do particles look like in flying objects? We have molten metal, chipping slag, high-speed particles. Sometimes tool fragments come apart, or the stuff you're pushing off a tool can get into your eye. Quite traumatic incidents, often very painful. You're typically looking at a lost time if you actually pierce your eye. No big surprise here. Immediate medical attention, especially the bigger the object. Let's go look at a little smaller of an object, right? A foreign body. I don't know if people have seen this before, but if you look right on the edge, you'll see that blackish brown spot. That's actually called rust eye, is its typical name. What you have there is you have a small piece of carbon steel in their eye. It's been embedded in their eye, and it's actually rust you're looking at. An optician takes this out, then they have to actually take something that looks kind of like a dentist drill and debride that area in a few different segments, right? Because that's necrotic tissue around that. But what do we get? We get fume, dust, and swarf. Your eye can get it out most of the time, but sometimes it can't, right? Especially for this swarf, we can have some pretty sharp edges. We can actually embed in the eye. The very second this happens, you have, quite a bit happening. You're scratching, all kinds of stuff. But just another case, especially in welding. How do we prevent some of these things? We use ANSI rated equipment. I wanted to show this little video just to explain the difference between a few things. So if I take a look at safety glasses, welding helmets, goggles, face shields, head iron face equipment, it's ANSI Z87 rated here in the US. Here's an example of a 1/4 inch BB being shot at 150 feet per second. This one's coming in a little hot at 160, but this is an impact test that a welding helmet has to take and safety glasses have to take. This is just one of the orientations that it has to take. It actually shoots it, I don't know, 0, 30, 60, 90, plus and minus 10 millimeters, because it's looking at different ways to get to the soft body of your eye. But if people haven't seen that before, it's pretty profound. But to step it up a notch is a face shield test. This one is the same 1/4 inch BB at 300 feet per second. And I always like to mention this because if we go from 150 to 300, people kind of lose the impact amount. Because how it really goes is 1/2 mv squared. If I double the velocity, I have 4 times the amount of energy. This is, from an energy standpoint, 4 times the hit that the first one has. And ultimately, this is what we're designing to. I say that because a face shield is far more robust than safety glasses. So let's just take a look at it by category. Safety glasses and welding helmets only have to meet 150 in these tests. Goggles, full face respirators, have to meet 250. Face shields, some integrated products, and some welding helmets are rated to a face shield, which is 300. And this may be a bit confusing because some welding helmets say 300 and some say 150. From a 3M standpoint, when we involve grinding with the welding helmet, we'll actually say it, and we'll call it a face shield in certain instances. Because we feel if we gave you grinding features within that welding ADF, that we want that 300. On some more simple welding helmets, 150. Keep that in mind as you look at any welding helmet. It's really only needs to be at 150. But ideally, in some applications, you want 300, in my opinion. Moving on, Because we are welding, we're going to talk about arc radiation hazards. And I do like to show this slide. It's pretty simple. That's a blister on his eye. It's a UV burn. You know, no different than me going out in the sun here in the spring and not putting on sunscreen. I'm going to get a brown, I'm going to get a burn if I don't. Your eye can get burned quite easily too. And how does it generally work? A lot of people don't really put this together, but radio waves, gamma rays, X-rays, it's all electromagnetic spectrum, and we humans can see a little piece of it. That's the visible light we see. Below us, to the left on this graph, is UV light, the stuff we know that burns us. To the right is IR light, the stuff that keeps things warm when you see an IR light source. So both of those have effects. And the one thing I do want to point out when you look at this graph, if you look at visible light and you start going from right to left, it is getting more powerful, substantially more powerful as you move from right to left. UV on the surface of the earth is called UVA. Keep walking down UV, there's something called UVB, maybe 5% on the earth's surface. But then there's actually UVC, which ends up right next to X-rays. There's none of that from the sun on the surface of the earth. But if we weld, we can actually produce those frequencies. So we can produce pretty powerful light, which can burn you quite quickly. Let's just take a look at these different components of light and how they would affect you. UV. We all know it'll burn us. But in welding, as I pointed out, we could have more powerful UV light. So we can burn ourselves in milliseconds. We can do it with an immediate burn, or we could add up the power over time and have damage from that too. Short term, what'll happen? You burnt yourself. It's literally what you've done. Itchy, arc eye, photokeratosis is its real name. But in the long terms, I don't think this will surprise anybody. You will start messing up components of your eye, things like cataracts. And because if we repeatedly burn ourselves just like our skin, different types of cancer, malignant melanomas. Eye arc is actually classified UV radiation as a carcinogen. Visible light. This one's a little different. It's what we can see. But keep in mind, we're producing a very powerful visible light. So we have to be careful of that because we can now take it into our eye. It doesn't stop on the outside of our eye and burn it like the UV did. We can actually take in high doses of visible light. Over time, that can have effects on our macula and retina, right? Because now what we've done is we've basically tuned our eye to take in these frequencies. We have no physical feeling nerves in the back of our eye. We're blasting our retina with high powered visible light, and that can lead to things like macular degeneration. Lastly, IR light, the other side of the spectrum. This one takes time. This one is approaching microwaves. So what we're really doing is we're vibrating water molecules and heating things up. At the end of the day, it's not good to heat up parts of our body that we don't want heated up. So we have to protect ourselves from this too. What do we do about that? We have to block the light. We can do it a couple ways. We can use a traditional welding passive filter, but well, we actually have these at 3M too. But what I'm going to talk about is an active filter, an auto-darkening filter. We 3M actually have the original patents on this. They cost little money, but there's definite advantages of using these. So let me just kind of show you how one works. Here's an auto-darkening filter. I'm going to go through those layers in some level of detail, but ultimately I'm going to weld. It's going to go dark. And when I'm not welding, it goes into a light state so I can see. Otherwise, you use a passive filter, and unless you're welding, you're not seeing through that passive filter. You know, a general shade is shade 10 here in the US. It's pretty heavily used. You're not seeing through that in normal light. But let's go into some detail of what this thing is. If you look at anybody's auto-darkening filters, they do very similar things. Like I said, we're the ones who originally invented this, but let's just talk about it in generalities. What you have on the outside when you look at these auto-darkening filters is you'll look at something and you'll go, well, it's purple, it's blue. It's really not a color. It's a IR UV bandpass filter. That's going to help us set the color. And then behind it, we have polarizing filters and liquid crystals. I'm looking at a computer screen right now, and there's a TV screen behind me, and I have my phone sitting here too. It's the same thing. They're using polarizing filters and liquid crystals. I'll give some examples of how they work and what they're doing. But if we look at that object on the far left, right, light is coming through that UV IR bandpass filter, going through the polarizers and liquid crystals and hitting your eye. So let's start with the UV IR bandpass filter. What that does is it inherently absorbs UV energy and bounces IR energy, leaving you with some visible light. Let's take a look at this graph. And what I'm looking at right now is the purplish object in the center of this one. On the y-axis, the up and down, is transmission. If I was looking through a regular pane of glass in transmission, that would be, 95%. And I would see all colors, but I'm not. Because the bottom one here is UV, visible light, and IR. So let's look at the purple one. Notice how there's hardly no component. And I have to say hardly none, because there is some. We can actually measure it. We measure transmission as a function of wavelength. That's how we get a graph like this. But I can't blow it up enough to show you the little bit that's in the UV or IR. But in general, if we're looking at the purple graph, we're coming from left to right. And I look at its peak. If I look at its peak, I just follow that straight down and I go, huh, everything's green. If you look through an older welding filter, most things will appear very green to you. It's because that is the transmission color you're seeing the most. There is hardly no blues, hardly no reds. And then we, again, block IRs in this. That's why they're very green. To build on that, when you're welding, you're actually looking at your weld puddle and you're trying to discern when to move. So color does become important. So I'm going to take in that graph behind there. I don't know, the lighter purple, I would say, for me. That is another transmission curve that we have in some of our welding filters, such as our XXI, our natural color ones. What we're trying to do is allow more visible colors in what you can see. A few things with that, as I talked about before, how dangerous UV can become. Even dark purples and blues become a problem in human vision. So you'll never see that graph extend all the way into the blues. So that's how those filters work. That's what that first layer is doing, absorbing UV and bouncing IR and giving you some colors that you can view. And then the next one is, how do we make it dark? We use liquid crystals. It's called a twisted harmonic liquid crystal. And polarizers. They're linear polarizers. So let's just look at the graph or the image on the left. So there's a linear polarizer sitting in there. What happens is light's approaching it from every direction and every angle. The only light that makes it through, though, has to be linear to that polarizer. That's why we get a kind of a flat line in this image. Then it hits a liquid crystal. The thing about the liquid crystal is, it's called a twisted harmonic. It can turn that light ray 90 degrees. So when the liquid crystal is aligned, it twists lights 90 degrees and hits the next polarizer, which is now in alignment with it, and light continues on at a minimal loss. But that's in its light state. We want to make it dark. We can actually change that liquid crystal to not allow it to twist that light. So now what happens is light comes through, and now I'm looking at the image on the right. Light comes through, it never turns 90 degrees. It hits the next polarizer, And because those slats are going up and down, it doesn't want light that's horizontal. It blocks it to the best of its ability. So what we do, we have that UV bandpass filter on the outside, and we have layers of these liquid crystals and polarizers. And it really depends how many shades we give you, right? Some helmets don't have a big array of shades, some have a huge array of shades. So I think we have somewhere between 2 to 5 liquid crystal polarizer segments in our different helmets according to what we're doing. One thing that I always want to point out in this little bit, because that's how they basically work, is to just jump back to that bandpass filter. Because the liquid crystal was an electronic component. We need electricity to turn it on, turn it off. That bandpass filter, though, is truly passive. Those UV and IR components are always active. ANSI makes a statement that says you must protect in the darkest shade that you have to the lightest shade you have to the same IR and UV levels. So what that means is if I have a helmet that's shade 3 to 13, the UV and IR components for the requirements for shade 13 must still be met in a shade 3, and that's to protect the user. And that's for all ANSI Z87 approved helmets. But thank you very much for your time. And over to Shane.
All right, so I will turn on video so you can see me here. So Shane Rose, I am a segment marketing leader for the personal safety division aligned to manufacturing, similar to Scott Shin. He's on the technical side. And I want to take a moment to look at this picture because what I want to do is kind of bring this all together. So we talked about a lot of the different hazards. We talked about a lot of the different types of protection. And so when you look at this picture here, you can see the answer is already there to the question, but how many types of 3M PPE is this worker wearing? And in this case, they're wearing 5. So they are wearing, oh, there we go. They're wearing head protection, which is integrated into the helmet that they have attached to the PAPR, the blower that's around their waist. They're also utilizing eye protection. In this case, they have a primary, so an eyeglass, as well as a secondary, which would be that face shield that's attached to the helmet. They have the face protection. They also have hearing protection with a muff that's attached to that helmet. And then the PAPR, the blower that's on their waist, is providing respiratory protection. And I just want to take a moment to look at this because this is kind of a pinnacle situation around integrated protection. And so when you think about this device that he's wearing, it includes a blower that has a filter that's pulling in air, sending it through the breathing tube into that helmet. And so that helmet in and of itself, attached to that, has 4 different types of protection to help protect against multiple types of hazards that worker could be doing in the grinding or any other application that they're potentially doing during their shift. And so this is essentially, you have 3 products. You have that PAPR that has the helmet, you've got the earmuffs that you can attach, and you have an eyewear. Now, if you think about this worker in another situation where maybe they don't have this specific type of device, they're still going to need all that protection. And when you think about how that impacts what they're wearing, it's going to look a little bit different. So they're either going to have a disposable respirator or a reusable respirator. They will still have to have that eyewear. They will potentially need to have a helmet of some sort with a face shield. And then, if their helmet doesn't have that attached or integrated hearing protection, then they're going to need earplugs. Now you turn this into many, many different types of PPE versus kind of one integrated solution that this worker could be wearing. And so that's where we get into our integrated protection program. And really, this is just talking about 5 pillars to help ensure that the worker can achieve 100% wear time, because that's when they're going to be able to be the most protected, go home at the end of the day, as well as retire in a healthy and safe manner. And so there's 5 pillars that we really address within kind of this integrated protection program, and they're on the screen here. So you have communication. Is that worker able to effectively communicate while they are doing the work? So what that means in application is if they're on a shop floor, are they going to have to potentially take off a respirator to talk to somebody? Are they going to have to take out that hearing protection to be able to hear somebody? And if you do that, then you're decreasing the effectiveness of that PPE unless they go into an uncontaminated space, which ultimately at the end of the day is reducing their efficiency and productivity. And so having PPE that can help facilitate effective communication can help ensure that 100% wear time. Additionally, is the PPE compatible? Does it work well together? And so if you think back to that image that I showed with the PAPR, with the helmet that had the integrated protection pieces within it, that's designed to work together. And you can have PPE that also works together that isn't an integrated solution like that. However, if you're thinking about just eyewear, and then if you're having a separate conversation or thinking separately about respiratory protection, and then you're doing the same for hearing or head protection, when you think about those things individually, you could potentially be selecting PPE inadvertently that may not be compatible with each other. So one kind of easy example to understand is if you have somebody wearing safety glasses, but they're also wearing an ear muff, a passive ear muff. That temple thickness can actually impact and decrease if it is big enough or wide enough, can decrease the effectiveness. It can allow additional noise into that earmuff that is unintended and actually reduce the protection that they're getting from that earmuff. So thinking about the different types of PPE that the worker would be wearing together to make sure that they are compatible. And if you are doing any sort of fit testing, whether it's hearing, respiratory, eye, or any other type of PPE fit testing, testing those together is important. So if you're doing hearing protection testing, making sure that if it is a muff, you're testing it with those safety glasses on to make sure that you're understanding the full impact of those PPE pieces working together. The third one would be comfort. And this is a very important one because oftentimes workers have to wear this PPE for 6, 8, maybe 10 hours a day. And so if that PPE is not comfortable, chances are they're going to either take it off to get some relief or they're not going to be as productive as they could be because they're being hindered by having to readjust or they're going to have to go and take more breaks. And so if you can provide PPE that is more comfortable, factor that into your selection of PPE, that's going to allow that worker to, again, keep the PPE on when they need to help get to that 100% wear time. In addition, it's just going to make their job more comfortable. And so, especially in the situations we're in right now with worker shortages, skilled trades shortages, anything that we can do to help make those workers more comfortable is going to ultimately help keep them retained. And then fit. Fit is an important factor when considering PPE. Every body and face and ear canal, they're all shaped differently. People have different size and shaped faces, different sized and shaped bodies. Even when you think about hearing protection, your ear canal, everybody's ear canal is a little bit different. And so ensuring that when you're selecting the PPE, you're getting PPE that either has a wide range of sizes or shapes that it can accommodate, or selecting PPE that will, multiple types of PPE that will work for your entire workforce. And so if you're providing just one type of safety glass or one type of ear plug, the chances of that fitting everybody is going to be pretty small. And so even though you technically may be providing that protection, that piece of PPE, you could be potentially putting yourself at risk as an employer because they're not effectively being protected because the PPE may not actually fit them adequately. And then productivity. So this is one where we want to help ensure that if people are wearing PPE, they can be as productive as possible. If you think about it, the example here with the fogging eyeglasses, I wear glasses, and so sometimes when I'm wearing a respirator, if I'm clean shaven, a tight fitting respirator, I can have fogging where my glasses do get fogged up. And if you're wearing safety glasses, you can have the same thing. And so with the productivity piece, ensuring that that PPE does not hinder, hey, Mike, you want to take your mic off? Making sure that you do not hinder that worker's ability to be productive. And so ensuring the right type of PPE is being selected to reduce that at the end of the day. And so, with all this in mind, we talked about the hazards, we talked about the different types of protection, and the key message here is, keeping that worker safe as you can is going to really be assisted if we can get them to wearing their PPE 100% of the time. And to do that, thinking about these 5 pillars will really help achieve that goal. So if they can effectively communicate, if the PPE is compatible, if it's comfortable and it fits well and does not hinder their productivity, then we're pretty confident that we can get very near or to that 100% wear time. And so at this point, if you have questions, I have one more thing that I wanted to touch on, but there is the Q&A, so please put in questions. We have a little bit of time for Mike and Scott if you wanted to ask them some questions, so put those in. But the one thing that I wanted to mention here is we do have our 3M Demo Center of Excellence. And so with this, for some of our products like our Speed Glass welding helmets, or our VersaFlow PAPRs, or our Peltor communication devices, we actually have the ability to help get those into your facility so you can test them out in your environments. And so you can do that by working with a 3M safety specialist. So there is a link on here, and we'll provide it after, where you can find your local 3M sales rep, get in contact with them. They can request the Speed Glass helmet, or the Peltor comms device, or the VersaFlow PAPR, and then bring it to you, where you can then keep it for a week, test it out in your shop or your environment, get it on the people, see how it looks, feels, and then kind of make a decision on if it's something that you're interested from there. So at this point, I'll stop and see if there's any questions, and it looks like we might have one for Scott. So I'm going to hand the microphone over to Scott Shin, 3M Scott. And if you want to kind of summarize that question and give a response, if that's fair.
I got this one. Yeah, I can summarize that. So the question is regarding supplied air respirators and the connections for supplied air systems. So OSHA requires a couple different things for supplied air systems. One is the need to supply what they call grade D breathable air, and this typically requires some sort of filtration system to remove dirt particles, water vapor, oil, mist, odor, that sort of thing. And then there's a requirement that any fittings, any connections to this supplied air system must be incompatible with other air sources at the site. So, and this is to prevent a respirator user from inadvertently connecting to a non-breathable air source. Right now, in most cases, if they connect to a plant air source, it might be dirty air. It's not going to be generally hazardous, but there have been cases where someone has connected a respirator line into, say, a nitrogen tank or an oxygen line and has caused fatalities. So it is very important that those rules be followed. And we do offer several different styles of connections or fittings for 3M systems. So typically come with an industrial interchange fitting, but you can get those with a Schrader fitting, and I think we have one other model. So, um, so the person that asked this question, reach out to your distributor, 3M sales rep, or we have a tech line that you can contact for help right away. It's 1-800-243-4630, and we'll put that in the chat as well. So reach out to them and they can help you out with other fittings.
Thanks, Scott.
Yeah.
Yeah, and so we did have another question here related to some PPE that 3M does not manufacture, and so it's not something that we generally speak to, directly if it's something that we don't, make, manufacture, or have expertise to speak to that. And so what I would suggest in that case is you found this webinar through the, affiliated distributors. So you're all working with, I would assume, an affiliated distributor or have the ability to contact somebody within the affiliated distributor network. And I would say your first step would be to reach out to one of those distributors to if you have questions related to some of the other types of PPE that we don't manufacture. That would be the suggestion there. Did we have one other question?
So I was going to say, that said, we do have accessories for some of our speed glass welding helmets and hoods for extended skate coverage. So Mike, maybe you can add clarity to that, but different options for skate coverage.
We're talking about like shrouds, things like that.
Let's take a look here. So not hand, but with the hoods, with the welding helmets, there's a ton of configurations, frankly. There's different plows, different bibs, different shrouds that encompass your full neck, different headpieces that will cover your entire head with all those different welding helmets that I showed. Even in this image right here, you're looking at someone with a different plow on. But yes, we can fully encompass your head with different skin protection. And again, I would just reach out to that tech line if you're not familiar with it. They'll show you anything you want.
Okay.
Yeah, and I was
So
gonna
think
jump
that
in
was-
on Shane's comments. Sorry, talking over top of you for a second, but we definitely will have hand protection webinars coming up. Superior Glove's a big partner and an AD member as well. And I did drop in just a link in the chat to our Safeopedia community. So that's a free community to join. And we do have ongoing conversations like this one today. And we do invite presenters back to dive a little deeper. So definitely sign up and watch for some of the hand protection specific sessions that we're running if that's a topic you're interested in. Sorry, Shane.
No, I was just going to say, I wanted to, on the behalf of everybody here in the room. So again, we have Scott Shin and Mike Halleck, Mike Halleck, there's only one of you. There could only ever be one of you, who are representing our application engineer group. They are really truly our 3M experts around different segments or applications or types of PPE. And then in the room as well, we had Tyler, who is our expertise delivery manager, and then again, Shane Rose, segment marketing leader. So just wanted to thank you all on behalf of us all. And actually, maybe we have one more question.
Yeah, we do.
Okay.
Yeah, one more question came in on air sampling, and this is a lot of debate on this topic. So the question is, any reported issues with conducting air sampling inside the welder's helmet with 3M designs? So OSHA compliance officers follow their standards. OSHA compliance will always sample inside the welder's helmet, right? Assuming it is not a respiratory helmet, right? So I would suggest, right, we always suggest if OSHA is conducting sampling, you conduct your own sampling in the same method that they do. So if it's a non-respiratory welding helmet, there are no issues at all with conducting that sampling inside the helmet if you can find, somewhere to connect that sample train to. But if that user is wearing a supplied air respirator or PAPR, right, with a hood, helmet, that sort of thing, you cannot break the seal of that respirator, right? So you cannot sample inside the welding helmet with a supplied air or a powered air purifying respirator. So I hope that makes sense.
Yeah, and one more comment on that, that especially is something that I always find relevant to welders in particular. I have a beard. I don't want to shave my beard. And I don't think a lot of welders want to shave their beards if they have one. So I pulled back this slide, and I'll just make this very brief. So the two respiratory devices that are on the left, you have the disposable respirator, which is the white cup style, and then you have a half face piece reusable respirator in the middle with particulate filters. Those two are considered tight face fitting respirators. And to effectively use those, and per our instructions on how to use those, you have to be clean shaven, no stubble, completely clean shaven, because they rely on creating a seal around your nose and mouth to effectively route that air through the filter media. On the right side, though, you have a G501. This is a welding helmet, welding and grinding helmet. It's got the integrated face shield. It's got the flip up visor. So you can flip that up when you're grinding, flip it back down when you're welding. And then it has the AdFlow PAPR, which is a purifying air or powered air purifying respirator. And what that's doing is pulling in air, filtering it, and sending it into that helmet. It is considered a loose fitting respiratory device. So it has a shroud that goes under. You do not have to be clean shaven if you wear a solution like that. And so on the left, disposable, reusable respirator, tight fitting, need to have a clean shave. On the right, if you have an integrated, a respiratory integrated helmet, you do not have to be clean shaven to wear and effectively use that device. So I will end with that because I don't want to shave my beard.
I don't want to shave beard.
Yeah. All right.
Well,
Anything else from anyone? Otherwise, Scott. Oh,
Yeah.
one more question.
One more question that just came in. Do you recommend the larger reusable respirators or smaller ones that can fit under welding hoods? All that are for shaven ones. So is there a popular reusable or disposable respirator for welding specifically?
Well, no, not specifically for welding, right? So for, I guess, we talk about large or small, right? There's a sizing, right? Small, medium, large, right? So the wearer always needs to be fit tested with the size, right? That they're able to get a good seal and they pass the fit test. So, but the other element is like profile. Some respirators have a larger profile, some have a smaller profile. So you may need to experiment with different types, different models of respirators to find one that fits best under your welding helmet. And again, some welding helmets adjust in and out, which can accommodate that. Others don't. So it's really specific. I don't know, Mike, if you had anything to add.
No, I'd stay just in vein with that, right? All of our helmets will actually adjust from your sneak your nose out. So we can put in people with different size facial features, put in people with different size glasses and respirators.
You're talking about the helmets.
Yeah, the helmet itself will actually, the welding shield will go in and out according to adjustments on the suspension on all of ours, just so we can put in different things, right? So we never know if you're going to wear a respirator, if you're going to have very big glasses. But one thing that I generally look at when I look at these is make sure the filter media is contained within the welding helmet, especially if we're getting a lot of direct hits from swarf and spark and spatter, right? I don't want to see this media exposed on the outside and getting blasted with different welding ones. Right here we show an RR and DR example that I commonly see in use in industry. It's really good. Thanks.
well,
All right.
that's great. It was great to see all those questions come in. And we're just at the top of the hour, so want to thank 3M and bringing all of this expertise and insight to the webinar today. Really appreciate that. Thank you so much. And thank everybody for joining us again, choosing to spend your time with us. I mentioned the Safeopedia community. I'll just drop the link in there again quick in the chat. but it's a free community again where we can come in and continue these conversations. We'll send out a follow-up email next week, early next week. It'll have a link to the recording, and we'll share the slides as well with you. And again, big thanks to everybody for the important work that you do, keeping coworkers and workplaces safe. Thank you again, everyone, and take care and stay safe.